y equals x plus 4 over x squared. Now this function is actually a cubic on top in disguise. It's written in the way that we want to work out the asymptote. So there's a hint for what's ahead. This is written as a mixed fraction, a quotient and a remainder. The remainder is when divided by x squared. So if I multiply this by x squared, I'll be able to add the fraction, x cubed plus 4 over x squared. Let's have a go at sketching it. Intercepts. For the y-intercept, set x equal to 0. We have a problem. If x is 0, I can't give you a value for y. Y is undefined. That actually means we've got a vertical asymptote at x equals 0, but I'll leave that until we get to discontinuities. For the x-intercepts, set y equal to 0. Well, y is my function. Which way is going to be easier? Probably this way. X cubed plus 4 over x squared. Because then I only need the top to be 0. 0 is x cubed plus 4. X cubed is 4. And x is the cubed root of 4. Wait, I've done something wrong here. That has to be negative 4, negative 4. Okay. Now, I'll give you an exact value for that. Well, I'll give you an approximate value. It's about 1.6. Don't worry about trying to get this exactly. You don't need to get this decimal correct. You just need to know, well, the square root of 4 is 2, so it's going to be between 1 and 2. Really doesn't matter exactly. When we come to drawing our sketch later, you'll see how it doesn't really matter. Okay, discontinuities. My graph is discontinuous when the bottom of this fraction is 0, when x equals 0. That, as we said earlier, is a vertical asymptote. What about extremities? As x approaches plus or minus infinity, what's y doing? Well, the function was helpfully provided for us as a mixed function already, so I don't have to do this division, although the fact that it's only x squared on the bottom means it would be fairly simple. As x approaches infinity, this term becomes 0, and I'm left with y equals x. Y approaches x, and that gives me a horizontal asymptote. Not horizontal at all. Made that mistake last time I did one of these. It's an oblique asymptote. It's linear, but it's not horizontal. All right, asymptote. Does my graph ever cross this asymptote? And the answer is no, because this term will never be 0. It's always x plus something. And in fact, it's always going to be above at the extremities because this term is always greater than 0. So it's always y equals x plus something. Graph is always above y equals x. That's going to be helpful for sketching. I think we actually have almost all the information we need to draw a sketch. Let's get started. So I know I've got an asymptote, a vertical asymptote at x equals 0. I've got an oblique asymptote at y equals x. And I know my function is always above this asymptote. So that actually tells me already where the graph's going to go. It's going to come down here, and it's going to come like this. I know the coordinates of this point. That is the cubed root of -4. This point is the cubed root of -4, 0. And this is why I say you didn't need to know exactly what that was. You just needed to know it was close to that axis. I would like to know, if I can, the coordinates of this turning point here. To do that, I need to differentiate. So, let me rewrite my function. Y equals x plus 4 on x squared. I'm going to rewrite that like this, x to the -2, because that's much easier to differentiate. So y dashed then is 1 plus -8 x to the -3. Okay, that's 0 when 1 equals 8x to the -3, which means x cubed must be 8, x must be the cubed root of 8, which is 2. And if x is 2, what's y? At this point, y is 2 plus 4 over 2 squared. Well, that's 4 over 4, so it's 2 plus 1, which is 3. So the coordinates of this turning point are 1 across and 3 up. And I have already drawn enough information on there to make a reasonable sketch.